Hi everyone, welcome to the first episode of our Codant channel. In this first episode, we will be discussing on the topic Git. We will be focusing on how Git works under the hood. As software developers, we are pretty sure aware that Git is a distributed version control system which will keep track our file changes. But what most of us are not aware is what happens when we do a file change and commit it. How is Git tracking all the changes occurred to the file? What happens when we do a branch switch? So, in this video, we will have a deep dive understanding on how Git works behind the scenes. Without further delay, let's start the topic. Before that, if you guys are new to this channel and very much interested to know technical stuff like this, do subscribe my channel. Now, let's go to the topic. To start with Git, we have to initialize a Git repository inside a particular folder where we have to track the changes. So for that, what we will do, we will create a sample folder. In that sample folder, we will initialize a Git repository and we will see how it will track the file changes and what happens inside the .git folder where it will actually track the changes. So for this, the prerequisites are you should have a Git installed in your system. So, getting ahead with folder creation, we will use a create folder command mkdir and create a sample folder named git sample. We will enter inside the git sample folder using cd git sample command. Now we will initialize a git repository. So to initialize a git repository, we have to run a command named git init. So once we run this command, it will initialize a Git repository inside the Git sample folder. So whatever changes we do in the Git sample folder will be tracked inside the .git folder. Where is the .git folder? It will be there inside the Git sample. So it will be a hidden folder. You should enable the view hidden files. So whenever you run this command, it is showing initialized empty Git repository in the Git sample.git folder. Let's open the .git folder. What is there? We will see. So we are in the Git sample folder. Inside that .git folder is created. So we can see there are folders and files which are created automatically when we run the git init command. Here we will be concentrating on one main folder named objects. In this objects, as of now, it is empty. There is no data here. But when we do the file changes later, there will be a objects which will be added. So Git file system deals with four types of Git objects: blob, tree, commit, annotated tag. Any type of file extension, like it may be a photo, video, or any file extensions, will be stored as blob. Let's say we create a Python code in one file naming an extension as .py. The file content, what it is there in the .py file, will be stored as a blob in Git file system. Information or a directories or a folder name will be stored as a tree. Multiple trees can be a subset of one tree, and even multiple set of blobs can be a child of one tree. Coming to the commit object type, different versions of the file will be saved as a commit object type. Annotated tag is a text pointer to a specific commit. So we will be concentrating mainly on blob, tree and commit object type. Let's take one example. By creating one file and committing it, what will happen inside the .git folder? What all object types will be created? Before going to that example, Git is a content addressable file system. What do you mean by that? So if we save any object types, Git will return one unique key. What is that unique key? Unique key is a cryptographic hash key, that is a SHA-1 hash key. Which is 160 bits for 20 byte and 40 digit long hexadecimal digit. So why they are generating it? So as we know, the passwords are hash protected. Why it is that? It is only directional. If we have a data, if we have a content, then that can be converted to hash key, but it is not reversible. Like that, if we do any file change, then the new hash key will be generated for each object type and new object type will be saved in the Git. Let's go on to the practicals and see what is happening. So I am in a Git sample folder. So what I will do is I will create one file called git sample.txt. Inside this, I will just write the content. Hello world. And save it. So as we know, this will be in the unstaged state. If I go to the command prompt and see if I just want to see the status, I will just put on git status. I can see there will be untracked change. This will be in the working directory as an unchanged file. First we have to stage it and move it to the staging area. I will do a git add dot. So when I click on this git add dot, this git sample.txt will be moved to the staging area, here where the blob is created. So when we do this, inside the git folder there will be one object created, that is a blob. We can see the type also, and that will be generated with a new hash key. Let me add this. Now if you see the git status, see it will be in the staging area, but it is not committed yet. So there won't be any commit object created. So now if we go to the git folder, in the objects, see there is one new folder which is coming. Earlier there was only info and pack folders were there. Now the new folder is there, which is 3e. Inside this 3e there is a file with a different keyword. What is this keyword? As I mentioned earlier, this is a hash function key. So to see what is the content for this blob which is created, or whether it is a blob or not, we will just run a low level command by using this hash key. Let me copy this hash key. Just remember this 3e keyword. So we have to combine this hash key with this 3e so to get the value. So I will just go here and run the low level command git cat file -p. So p will give the content. If I am typing -t, it will give the type of the object. So I will just type 3e, that's the name of the folder, and paste the file key name. So if I run this, I should get the content hello world, which I have saved in the staging area. See, I got the hello world now. Next is, we want to check whether it is a blob or other object type. For that we have to use -t. So we will see that there is a blob which is created. Next step is to commit the changes. So when we commit the changes, there will be two things which is happening. It will create a tree. Means in the git sample there will be a tree which will be created where that file is located. So now tree will have a link to the blob, and the commit, what we are doing, that commit will have a link to the tree. So let me commit the changes and show you how it works. So I will just type git commit -n, and I will give initial commit. Just run it. So we can see that there is a one file changed and one insertion command, and it has created a mode, that is 1000644 git sample text. This 1000644 is a read write access. Now I will show you what happened in the git object folder. We can see there are another two folders which are created, that is 4e and da. So in that, one will be a tree and one will be a commit. Let's see which is commit and which is the tree by using the low level command again. Git cat file I'll just copy this -t 4e, and I will paste the file name. So this is a commit. So if we see what is the content in this commit, it will be having a link to the tree which is newly created. See this tree. This tree will have a file name, that is git sample.txt, and that git sample.txt content will be saved in the blob. It will be git cat file. So we can see the blob. So the tree will be linked to the blob, that is this blob, and it will show the file name, which is the file name, that is git sample.txt. So have one diagram where I can show you how it is linked. So when we commit, this commit object type will be having the data of the tree, and this tree will have a file name, and the content of the means it will be pointing to the object type blob. That blob will have a main content. So if we create a new change, then the new blob and a new tree and a new commit will be pointed, and the head, the master or the branch will be pointing to the recent commit which is available. So I will be sharing the article which I have written detailedly in that how the commit, tree and blob object types are created. That's it for today. We will meet next time with a new topic. Thank you.